For some reason, that sounded semi-sarcastic.
Say that every day.
Because we've had a lot of good lessons lately. This chapter has been, I'm not saying there haven't been parts where people have struggled and have been a little bit tricky, but this chapter has not been bad compared to some stuff we saw in Algebra 1B. Is that fair to say?
That was just a struggle for us the whole
Last try?
Yeah, that was.
Yeah. So far, this chapter is pretty manageable. And this is our last lesson in the chapter. So maybe at the end of the hour today, I'll get you the test review. But tomorrow we're going to test review, and then Thursday we will test.
Are you kidding me?
No, sorry. Is that okay?
No.
Why?
Because it's too early for us.
We got to get a test and a quiz in before we go on spring break. One more test, one more quiz. What? Well, next week on Thursday.
That's a long story.
I know. So we'll quiz, and then maybe we'll think of something fun to do the second half of the hour.
Or we could just not go to
Or we could quiz Wednesday and just watch chill on Friday.
Well, I don't think we'll be ready for the quiz on Wednesday yet.
I don't know.
No, because we're learning new stuff on Wednesday.
Well, we're good for 9 students.
Yeah, we have 9.
Yeah, so we should be able to do it fast enough.
All right, we'll find out. We'll try to squeeze everything together.
Every lesson on the day.
You guys will do everything on the weekend.
No.
No. No one wants to do homework on the weekend. I don't want to grade your homework on the weekend.
I don't have anything to do on the weekend.
Anyway, all right, this is what we're looking at today. Comparing linear, lines, exponential, not lines, and quadratic, loops. Okay, we're comparing every type of function that we've seen so far. So you started out Algebra 1 looking at linear functions or lines, and then in the middle of chapter 6 or 7, I can't remember now. Middle of chapter, I think it was 6, we looked at exponential growth and exponential decay, remember, and compound interest and all that good stuff. And then now we've talked about quadratic functions. So what we're doing in this lesson is comparing all of those things and looking at tables, looking at graphs and stuff, and thinking about how can we know if we're talking about a line, an exponential function, or a parabola with a quadratic function. We do not have a warm-up. I've been slacking on warm-ups this try so far. Students will be able to identify the difference between linear, exponential, and quadratic functions. So they might give you a table, or they might just give you some points, or they might give you graphs, and you've got to know which one is linear, quadratic, or what's the other one? Exponential. There we go. So not a super long like lecture-lesson today. So there is a lot of parts where you guys can participate. So as long as we participate right away, then it'll be no big deal. A lot of points. Tell whether the points represent a line, exponential function, or quadratic function. So this is a problem that is just like what will be on your homework. With letter A, we're going to plot those points. So 4, 2, 0, 0, 0, 1, I'm messing it up. 4, 4, 2, 0, 0, 0, 1, negative 1/2, negative 2, 4. Oh, I did mess something up. So if we connect those lines, not necessarily in the order that they give us, but if we connect those dots, what do we get? A parabola. So that would be quadratic. Don't get stuck connecting those dots in the order they give it to you. If we connected those in the order they gave it to us, then it would look like this. It would look kind of goofy. You'd have like a loop right around here. That's kind of hard to see for you guys. But we need to plot our points and then try to shape them in a way that represents one of our functions. So that first one would be quadratic and be a parabola. Second one, we're at 0, 1, 2, 1, 2, 4, 2, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1, start to see what this is going to be. -4, -5. We connect our points, what do we get? What kind of function is that, Mari? Yeah, linear, it's just a line. Nice job. Last one. We've got 0, 2, 2, 8, 1, -4, and then -2, 1/2. Positive 1/2. Now, if we kind of sketch this graph, then what type of graph? It's not a line, right? It kind of loops down on the left side. It's not quadratic because it doesn't come all the way back up. What would this one be? Exponential. Yep. This would be exponential. So that is what a lot of your homework problems will look like. Or maybe not a lot. There's not a whole lot of them in general, but some of them will look like. They'll give you points. You plot it. You got to sketch those points together and decide what type of graph. Can we do that? Yeah, that's not too bad. Maybe, we'll find out. They also will give you a table, okay? So don't write this whole slide down because that's a lot, but just listen as we talk through it. They also will give you a table. So when we look at the table of a linear function, notice that we have a constant difference, right? Every time we are adding 2 of a linear function, of a line. If you think all the way back to Algebra 1A and 1B, we spent a lot of time with tables. And we said that the constant difference, what else do we call the constant difference? What would that be like in our equation? That constant difference is the slope, right? This is our slope, our rise over run. But that constant difference is what we would see with a line. What else? If they give you a table, what else could you do if you didn't want to try to find the constant difference? You could what? Yeah, you could just graph it. You got all your points, x and y. If we look at an exponential function at the table, what should be happening between each point? Right, we should be multiplying. Right now we might be multiplying by a fraction. It could be multiplying by 1/2 or 1/4. If you remember all the way back to that stuff. But a linear function will be adding the common difference. When it comes to an exponential function, we will be multiplying. Okay? Now, we haven't really talked about what a table would look like with a quadratic function, right? With these parabolas. We have, not spent a whole lot of time on it. What we should see with a parabola is what they talk about here. This idea of a second difference. Okay? We see between the kind of first difference, we see that it's -1, +1, +3, +5, and goes in that way, and it's kind of hard to see what type of pattern is going on. But if we look at the second difference here, then we will notice they're all +2. Okay? Now, like I said, you could, and like Leighton said, you could totally just graph these, which is probably, if I were doing it, that is the way I would do these. Is just graph these points, each of these, and then see what the graph gives me. Because it's way too easy to mess up on especially these exponential ones, and then finding this first and second difference. But even if you decide to graph all of them, I need you to know and understand the idea of the second difference, like you see in the bottom here, correct? Even though we might not use it a whole lot, do we understand what it's talking about with the second difference? second difference only becomes important when we're looking at a quadratic function or a parabola. Do you have any questions on that slide before we move on? Do we remember talking about this stuff with the linear function and the exponential? Does that kind of sound familiar? A little bit? So now they give us the table. Tell whether the table represents a linear, exponential, or quadratic. Like I said, we totally could just graph these. And we will do that just to check our answer. But if we're looking at these differences, our x's are going up all by 1. So our x's are all set. The y's are consistently going down minus 3. So what does that tell us? What type of function is that, Abby? I couldn't quite hear you. Yep. Yeah. Same slope. Consistently going down by negative 3. We can just quick check it, even if we don't plot every single point. Negative 3, 11 would be way up here. Negative 2, 8. Negative 1, 5. 0, 2. And we can see that that is forming a line. So we can even quick sketch a graph, just to make sure. Letter B. They kind of give it away just by having this slide right above it. So we probably can know that that's a quadratic because they give you the second difference here. But even if we weren't sure, we could graph that one as well. And we would see a nice loop. Any questions on that one? On that slide? Now, they are going to ask you to write equations based on some of these. So, we know 3 different forms of equations. What is the form of a linear equation? Right. Y equals mx plus b, where m is our slope and b is our y-intercept. What's the next one? Exponential. What is the form of an exponential equation? We talked about in chapter 6 or so. You don't know, look back through your notes. Y equals something, and then something. Hey, why aren't we writing anything down? What are your notes at? What? You don't know. It's not a good answer. Get some paper out, write something down. You're not helping yourself at all by not writing anything down.
Isn't it something with parentheses?
There's something with parentheses. You're in the right ballpark. That has to do with exponential, or the compound interest stuff that we looked at. The exponential in general. What was the equation that we used for that? You're on the right track. Yep, you're in the right area. You're still in the right area. Anyone find it yet? No? I don't think anybody, maybe 2 people actually will, but exponential equation was in general in this form.
Oh yeah, so I was right. Is that something else like isn't the one that you do? I said it very quietly, but have what.
Oh, okay. Typically in this form. And then the last one. Our quadratic, we're saying that it is in this form. Now we also, this would be our standard form. We also have vertex form. So when we're writing equations, they should be in one of these forms right here. And there aren't, I don't think there are too many. No, there are not too many where you need to write equations. Alright. Did I really make the class kick? I didn't think I did. But if there is one, it's pretty short. I know that for sure.